Today, let us learn about the logic gates and their applications in the real-time applications. So basically, logic gates are the electronic digital circuits which performs the logical function and which are used to implement the Boolean functions using these basic logic gates. So commonly expected logic functions are already having their corresponding logic circuits in the form of integrated circuits. Let us see the number of gates which are used to implement any algebraic function. So before going to all the gates, we have three basic logic gates, that is AND gate, OR gate and NOT gate. And using these three basic gates, further gates like NAND gate, NOR gate and the exclusive OR gate can be implemented, which are used to build the Boolean algebraic functions. So let us see the function and standard representation of these three basic gates one by one. So first we shall move on to the AND gate. AND gate is nothing but it is the implementation of the mathematical function called multiplication. So any function or any input which is given to the AND gate, it is ANDed and the output is obtained across this terminal. So this is the standard symbol of AND gate. It has two input terminals and one output terminal. Whatever the input which are given at these two terminals, they will be multiplied with each other and the corresponding output is expressed across this output terminal. Now let us see the truth table of this AND gate. So AND gate has two terminals A and B, and let this R be the output terminal. Whenever both the inputs are zeros, the output of AND gate is equal to 0. Similarly, the output will continue to be 0 till any one of this input terminal is equal to 0, and the output of this AND gate will be equal to 1 when both the inputs of this input terminal of AND gate is equal to 1. Now let us see the implementation of OR gate. OR gate implements the addition function, that is logically it is called as the OR function. So whatever the inputs which are given, they are added with each other and the respective value is represented across the output terminal. This is the standard form or the standard symbol of OR gate. And now let us see the truth table of this OR gate. So it has two input terminals and one output terminal. The output will be equal to 0 when both the inputs of this OR gate is zeros, and the output of all other combinations is equal to 1. It is because any one terminal of this input is equal to 1. So this represents the addition function. Next we shall move on to the NOT gate. NOT gate is also called as the inverse gate. Why? Because whatever the input which is given at the input terminal, it will be inversed and it is expressed across the output terminal. For example, if the input terminal given is equal to 1, then its inverse is equal to 0, which is represented across the output terminal. Similarly, if the input given is equal to 0, then the inverse is 1, which is represented across the output terminal. So hence NOT gate is called as the inverse gate, because as it inverses whatever the input given to it and the inverse output is obtained across the output terminal. Now let us derive some of other gates using the knowledge of these three basic gates. So among them, first one is the NAND gate. NAND gate is nothing but a combination of AND gate followed by the NOT gate. So whatever the input which are given across these two terminals, they will be ANDed first and then the output is inverted using this NOT gate, and hence we will get the output across the output terminal. For example, a logically high output is obtained when any one of this input terminal is equal to 0. So this is the logic symbol of NAND gate. And now let us see the truth table of NAND gate. So it has two input terminals, A and B, and R represents the output terminal. So whenever both the input terminals are zeros, the output of AND gate is 0, which is inversed to get the output equal to 1. Similarly, the output will continue to be 1 till any one of these inputs is equal to 0, and the output of this NAND gate is equal to 0 when both the inputs are equal to 1. Now let us see the building of NOR gate. NOR gate is nothing but a combination of OR gate followed by a NOT gate. It means that whatever the input which we feed across the input terminals, they will be added first, then the resulting output is inversed across this NOT gate and the output is obtained across this terminal. So this is the standard symbolism of NOR gate, and let us see the truth table of NOR gate. So NOR gate of course has two input terminals and one output column. So when both the inputs are zeros, the output of NOR gate will be equal to 1, because 0 plus 0 is equal to 0, which is nothing but the output of OR gate, and again it is inverted, which is equal to 1, and the rest of all the outputs of NOR gate are equal to zeros till any one of these input terminals is equal to 1. So this is regarding the NOR gate. Now let us move on to the XOR gate. So XOR gate, it is nothing but a combinational circuit which produces a logic 1 output only when its both the inputs are different, and it represents a logic 0 output when its both the inputs are same. So this represents the symbolism of XOR gate. It is a variation on the standard OR symbol. So it consists of a plus sign with a circle around it. So the logic symbol of this XOR gate is as shown. It is a variation of standard OR symbol.